Good morning to everyone all. So today we are going to take a topic on LED. So LED means light emitting diode. Okay. So light emitting diode is a semiconducting device. First of all, LED is a semiconducting device. It emits light energy. It emit light energy. So light, what is light? What is light? Light is a form of an energy. Light is a form of an energy. Here we are converting electrical energy into light energy by recombining electrons and holes. So what is the difference between the LED and the normal diode, light emitting diode and ordinary diode? In ordinary diode, it will passage the current from one side to the other side. But here, what is the role it can play? Instead of passing the current, it will emit some energy. That energy is nothing but as light energy. So this is the symbol. This is the symbol of the LED. So it consists of anode and cathode. So already ordinary diode is there, but here behind that we are drawing a small circle. So here it will show that the light ray can emit. This the real fact is shown in the symbol. Okay, this is the LED symbol. So LED is nothing but as light emitting diode. It is made up of semiconductor device. It will convert the electrical energy into the light energy. This is the basic principle behind the LED. And also how it is possible, because how it is possible means it will recombines the electrons and holes. And then now we are going to the principle. What is the principle behind the LED? So LED is nothing but as it is a particular diode which generate photons. Already we know that light is made up of packets of energy. Light waves, no. Light is considered as a particle as well as wave. So if you consider as a light wave, if you consider as a light, this is considered as light. So it is made up of photons. It will emit energy in terms of photons. Okay. So it is a stream of electron passing through it. When a current is passing through it, it will emit photon. The photons is considered to be the light. So it is having various characteristics. It should be a monochromatic as well as coherence in nature, and the phase difference is between the two rays is also same. So what are the principle or what are the characteristics obey the light rays? It's also follow the same that. Okay, so this is the principle behind that. So it is a light emitting diode, no? So that it containing both p-type and n-type material which are combined together to form the LED. Okay, next we are going to see about the construction. So this is the construction of the LED. So here substrate is nothing but as material which can able to place the n-type and p-type. Okay, so here is the n-type, here is the p-type, this is the active region. So here we are going to give some voltage behind the substrate. We are giving some voltage. Already we know that p-type material is a positive charge carrier, so we give positive charge. It requires some high amount of energy, so that only I am putting so many batteries. Okay, so in p-type, in n-type, so here negative. Okay, so it contains, already we know that in p-type material majority of charge carrier is holes. In n-type material, here the majority of charge carrier is electrons. So what happen if you are, when the passage of current is flowing towards the diode, instead of heating or conductivity takes place, it will emit energy. Okay, so here the dots, solid dots, will represent the free electrons. Okay, so next one is the hole. The hole is represented by the small white dots. So another one is the photons. The photon is represented by small dots. It will be emitting, no? If you look at the diagram, it will be emitting. So the photons means nothing but the energy. The energy will transfer from the conversion of energy from electrical energy into the light energy. That is the basic principle. Here the passage of photons is seen on the finger. Okay, so what happens if we are passing the current? So already we know that electrons is always moving opposite to the negative charge. So more number of electrons is occupying or pushed into the p-type region. And the other side here is the holes is moving towards this direction. So another question will arise: why the ordinary diode cannot emit electrons? Sorry, cannot emit energy in terms of light energy. Why this particular type of LED will emit light energy? Because the material used for the LED is different when compared to the ordinary diode. Okay, so that it will emit photons. So this is the common question will arise by all the science people. Okay, so here we record that more number of electrons is moving towards us, holes is moving towards us. Here the recombining will takes place. So it will emit photon. Now you enter into the energy level diagram. It is an energy level diagram. This is the energy level diagram. Here is the p-type. Here is the n-type. This is the energy level diagram. In p-type region, this n-type region. I already told that p-type region containing more number of holes and n-type region containing more number of electrons. Okay. So here n-type region is connected to electrons. P-type region is connected to positive of the battery, negative and then positive. Okay, so this is the diode. So in the diode it will emit energy. That energy is nothing but as light energy. Okay, so how it is possible? Here you look on this is the energy level diagram. So already you mentioned that valence band is there, Fermi energy level, band gap. So this is the band gap, Fermi energy level. There are two bands is there, valence band and then conduction band. The valence band containing more number of free electrons, and then conduction band containing more number of holes, If you are giving some energy, what will happen here? The holes is moving towards the electron is moving towards the hole. So there is a recombination process will take place, that is represented here. So recombination process will come. Normally if you are giving some energy to the electron which is present in the ground state, normally is going to the excited state, that is called as conduction band. Okay, so it cannot withstand to a very long time. After a nanosecond it will be recombined to the ground state, or it can be come to the ground state. Already we know that if you are giving some energy, it goes to the excited state. If it comes to the ground state, it will emit some energy, so that only it comes to the ground state. If the electron will come from conduction band to the valence band, it will lose some energy, no? Then only it comes to the ground state. So that energy in the form of light. This is the basic principle behind the LED. So one electron will come from ground excited state, that is this conduction state, to the ground state, or conduction band to the valence band. It will emit 1 photons. Likewise, so many electrons is present in the conduction band. Okay, so it come back to the valence band, that is means represent ground state. It come to the ground state, it will emit large amount of energy. Okay, this is the energy level diagram, how the LED works. Okay, I hope you all understand. If you are giving more amount of energy, more electron will goes from valence band to the conduction band. After the period of nanoseconds, it will combine to the valence band. While coming to the valence band, it must lose some energy. That loss of energy is nothing but as light energy. This is the basic principle behind the light emitting diode. It cannot happen in the ordinary diode. It happen only in the specific type of material that is called as LED, light emitting diode. Next we are going to see about the properties of LED, which is similar to the laser light, so that I am putting the title as properties of laser light. So it is a monochromatic. So whatever may be the LED, if the LED is emitting red color, it will only emit red color. Okay, if it emit yellow color, it will emit only yellow color. And then it is a monochromatic, and laser light is a monochromatic, and it is a directional, is similar to the light rays, and it is coherent. It seems to be same. All the light rays, it seems to be same. Okay. Unlike white light, we can able to make 7 colors VIBGR. By use of LED, if we go for any festival or any functions, we can see that numerous colors is coming to our eyes. So this may be possible only by the LED. Okay, so this is the main application, and it is a highly directional, and it is a coherent. Already told that, and all are in space, can able to pass the light waves into the space. And what is the use of LED? The LED is used in backlighting in television. So nowadays LCD is replaced by LED TVs. The cost is very low and is used for displays. In most of the TV monitors and computer monitors can be made by using only the LED, because the resolution of LED is very high, no? So that only we are using. It is used in automobiles we are using, and it is used in dimming of light. It is used in dimming of light. So many applications is there. So thank you for one and all.